Welcome everybody to Season 2, Episode 4 of the Quantum Analyst Roundtable. And we're going to start out with tremendous news for all the quantum computing lovers out there. President Research just informed us that the quantum computing market was $10.1 in 2022, and by 2030 will reach $125 billion. Isn't that amazing? And you can buy this report at presidentsresearch.com for $4,900, the price of a Starbucks latte pumpkin spice. What is really sad, though, I saw at least 3 quantum computing builders advertising it on LinkedIn and in pitch decks already. Some have not yet understood that 2023 is the year of change. Welcome, my friends, David, Doug, Shahin. James left us for large language models and something happening at Microsoft and Bing. Not sure what that is all about, but he'll be back next time. How are you all doing?
Doing great.
Excellent.
Yeah, good.
I always look forward to these sessions, and I'm waiting for us to get going. Yeah, thank you.
Well, Shahin, are you excited about 125 billion?
I think the only way is up, obviously.
I bought a yacht this morning, a small 200-footer. We'll report from that the next time.
Oh, I got an airplane.
Beautiful, pick me up.
Yeah.
It's good to start small, yes. Yeah. No, I don't know. I think when the growth is that incredible, it calls into question a lot of things. I think everybody agrees this market is a great market that's going to continue to grow, but wow, I think that's bigger than the cloud market.
if I was reflecting on this challenge, you've got to sympathize with the need of so many businesses out there that desperately want there to be some numbers, and you're preparing an investment case, you're trying to make a board decision. And you really want there to be some authoritative, independent figures out there that can be referenced, and unfortunately, people step up to fulfill that need, but you have to ask how robust, how trustworthy is that particular point of view, and equally, I think you have to reflect on this. You have to realize that there are different scenarios of how things can play out, scenarios that are very different. In terms of technically what ends up happening, and that then reflects, commercially, not just how large the commercial opportunity is in different segments, but also what strategies for different businesses, different products, different services navigate through that. And so while I'd love to say you can go in and make board decisions really simple, it's never really that simple.
One thing I would add is anyone that looks at these numbers, they got to be very, very careful about exactly what they're talking about with the numbers. Because some companies include quantum computing, quantum communications, quantum sensing all in one. Some actually talk about quantum value. And value is the value that goes to the end users. It's not the value that goes to the quantum providers, which is roughly about 20% of those numbers. And sometimes you really want to cheat, you'll quote a cumulative number, the cumulative number of the next 10 years. So, if you want to pump up a press release or an investor deck, there's lots of tricks to do it, and just come to me and I'll tell you how to do it.
and well, you 4,900 for one report.
Right.
Sticking to money, Doug, you made an interesting observation about venture capital in quantum computing. What was that exactly about the regional divide, I think?
Yeah, I track all the announced venture capital investments, and so far this year, there's actually been 10 outside of the U.S., in Europe and Australia and Japan and China, 0 inside the U.S. So, I think, the U.S. VCs are certainly getting cautious, and I think that's bleeding over, from some of the issues in the classical world, and I think that's bleeding over to the quantum industry now.
Yeah, I think the word from VCs as early as mid last year was to start extending your run rate dampening all the funding and telling their constituent companies to portfolio companies to go cut costs. And I think that is in some ways self-fulfilling, because when somebody does it, others get scared. It's also opportunistic. It's people who wanted to do it, and now they can say, well, everybody else is doing it. But it's almost a daily parade of people who are cutting 10 to 15%. That's in contrast with how much they grew in 2019 and 2020. So if you added 50% then, and now you're cutting 5%, you're still way ahead of the game. But that's yeah.
And if you're looking for something to spruce up your press release or pitch deck, as Doug pointed out, this is what I'm excited about. Every other technology that I can think back in the last 25 years that I've been doing this, it's always been US venture capital and US startups. And this is the first time that I see this not being the case. And it is certainly confirmed in our conversations with dozens of VC that we've had in the last few weeks. Just this morning, Terra Quantum, a Swiss-German quantum computing company, announced Investor Corp for an undisclosed amount. Oxford Ionics in the UK raised 30 million pounds. IonQ, actually, this is a strategic investment, not VC, but US-based, acquiring Entangled Networks. We have Welling raising a 5 million pre-seed company. Of course, the big whopper of the last couple weeks, Pascal raising a $100 million Euro round. Very well done there. Quantum sensing startup, our friend Mike in Australia, announced 27.4 million. And then we have another big whopper, Turingo, and not sure what the exact amount here is, but purportedly several hundred millions in a Series A. So much bigger check sizes than we've ever seen before. Outside the US, our friend Rob Hayes at Atom Computing, but that again is not a VC deal. But congratulations on your DARPA award. Got some more cash in the bank. But very interesting to see these larger checks and to see them overseas.
Just one thing I'd add. Obviously, the check sizes and regional locations is one aspect of VC, and obviously another crucial aspect to the actual valuations that these deals are being done at. And I think there is indication, really, if you look back at some of the deals, you know, when one's engaged in a VC process, you can see that evidence of the valuations being more generous, the multiples being more generous, you know, back effectively during the height of that initial bubble in 21. You can see that the valuations become more generous at that point, and then that they've tailed off again through 22. And I think we're seeing that then play out through the difficulty of getting the sustained interest now in the US market. And I can't help but think that pressure will ultimately import itself to other geographies.
I think the other thing I see in terms of funding, and I believe, at least, you know, we think that for the next 10, 15 years, there's going to be a disproportionate government activity in funding everywhere, not just in, you know, China, that has kind of known for, or for that matter, Europe. Well, but also in the US, we're seeing a lot of procurements kind of getting linked to that. So I think that is also an angle, and I think this is Europe's opportunity to catch up, because, you know, the US went through the whole SPAC craze and, you know, investment left and right, and maybe now is the time to. So I think that they're out of phase a little bit too, these investments.
Yeah, one other thing I would add is you see a lot of talk in the popular press about quantum as US versus China. And I think that's a mistake. You know, you can't ignore Europe. Europe in many cases is probably as strong as the US and China.
In fact, I think you can't ignore anybody, because the industry is at such formative stage that there's really no handwriting on the wall about anything yet. And as I like to say, where do you see quantum effects? Everywhere. So, and who knows quantum physics? Everybody, right? So India, the Middle East, Africa, Latin America, Oceania, all of those guys have pretty serious scientists who can crack the code or stumble upon it. It's really difficult to predict.
And we've recently been speaking to Dubai, but also Qatar. Now that the football World Cup is over, they are focusing on quantum. at GQI, we recently released our global government funding dashboard with somewhat different numbers than the popular press, a total of 55 billion across 29 national efforts, and China, of course, leading here, but a close second, Europe, and North America, frankly, far behind. I believe we mentioned the Israeli federal effort last time already, a small amount, but the largest budget ever by the Israeli Innovation Authority. In the US, the National Quantum Initiative finally got supplemented for the 2023 budget. Canada announced another federal national quantum strategy with 360 million. These are really small numbers compared to what we see not just in China, but in Europe, where we don't see anything under $1 billion, really. Let's look at the flip side of all this money and how that money is being spent. And this is why I gave this introduction a little pessimistically. In fact, the largest publicly known revenues in quantum is D-Wave with about 4 million quarterly. I suspect IBM might be a little bigger, but we don't know that. Jay, if you want to text us summary financial statements in the next 20 minutes, we can put that on the air. But small numbers, and we're seeing a lot of kind of issues here. D-Wave, there was a report, and we don't know what it is worse, but according to those journalists, is running out of cash after its SPAC.
Yeah, my view is that until we get to quantum advantage for a couple of applications, the classical hybrid emulator simulator market is probably going to be bigger than the end user revenue. I think, as you know, to Doug's earlier point about how you do market sizing, the other thing that we have done in quantum computing is to look at the entire supply chain as, you know, money changes hand. And what everybody really wants is like, what is the end user revenue? And as you mentioned, that continues to be pretty small. So that, I think, is a reflection on where the industry is that it's just like churning and trying to figure things out. And in fact, there's a period where a lot of progress can happen, where you don't get a lot of big headlines, but there's lab work that actually moves the ball forward. So I'm hopeful, but I believe no indication has come across yet.
I think one of the things about those SPAC deals, you know, whether it was IonQ, Rigetti, D-Wave, it is a relatively more opaque way of things happening, and I think it can obscure that there's big differences between those SPACs. You know, IonQ were right there timing at the height of a quantum bubble and at the height of the SPAC bubble, and it meant they raised a lot of money. And you look at the IonQ balance sheet now, you look at the valuation and the market cap, and you can see how it's buoyed up by that large pot of funds that they have available to implement and tailor and continue forward on their strategy, and that's got to be a very powerful tool for them in how to take this forward. Whereas you've got just was not as successful as that for Rigetti and D-Wave, and D-Wave in particular, it didn't really get the injection of funds that it was looking for at that point, and that puts it financially in a difficult place. It's a little bit off topic, but I'd love to come back a bit later, because actually there's some things that I only came across more recently, I hadn't appreciated before, that's made me a lot more excited about the D-Wave gate model approach than I previously understood. And so it's getting off the track of your question, Andre, but maybe I'll fit it in later when we talk about architecture.
We'll get back to it, and absolutely, IonQ got the SPAC timing right. They still have well above $500 million in cash in the bank. That's not what my bank account says. So congratulations to IonQ, and Doug, they just opened a plant. They are so bullish on quantum that they opened a plant. What's going on in that plant?
Well, you definitely need to start figuring out how you're going to build these things, and particularly their architecture might want to build these in volumes. One of the things that they announced over a year ago is the fact that they're working with, was it the Northwest? I can't remember the name of it in the Washington State, to get a source of barium. a good source of barium, which will be the next ion that they use for their next generation machine. So they need to put together a fairly significant facility to build these machines, build them in a little bit higher volume, as well as having a data center. I think right now, they're sort of limited in terms of what they can do in their facility in Maryland, and certainly more space. I believe it's a 65,000 square foot building, which gives them a lot of room for expansion for both manufacturing, research, as well as a second data center for them. So that will be a nice expansion, but again, it'll take several months, maybe a few years before it's going at full speed.
Another potential angle is that this is not a bad time to acquire facilities, because that market is down, and and I think their SPAC timing as well as this acquisition may very well point to their prowess in financial engineering in addition to just traditional engineering.
And I think last time I made the joke that we'll have a superposition of quantum winter and quantum summer. This is certainly what we're seeing here, a bifurcation in the market, but we remain bullish on D-Wave as well, and promise to David, we'll get back to that in a second. Unfortunately, on the more unpleasant side of news, of course, Chad Rigetti got replaced as CEO, and now Rigetti is facing delisting at the public stock market for compliance reasons, really because their enterprise value is falling below the listing limit. Not sure if this has really any predictive value on how their business is going or how their technology is doing, and personally I continue to hear good things about their technology and roadmap, and we know they have large federal contracts, but certainly a position that you don't want to be into. Anyone has any insights or comments on that?
Not insight, but sort of previous experience and exposure is that these things obviously don't sound good. They're not desirable. They are unpleasant. But in terms of impacting your day-to-day business, it is minimal. And I hope that that's what, in fact, it is the case now.
Well, they have a new CEO now who just came in, and I'm sure he's trying to figure out what to do and maybe what deals to make. But he did make a public comment, which I think is relevant, which is he's going to put a lot more emphasis on improving qubit quality. So I think that you'll see improved fidelities coming from Rigetti and some of their next generation machines.
One thing I'd just reflect on, I think we maybe don't talk enough about the IP portfolios of some of these companies. Rigetti clearly has value as an ongoing team of people that know how to do stuff and take the frontier of what's possible forward, like the qubit fidelity work Doug's referring to. But they're also they're presumably sitting on some very, very interesting patents. I mean, in particular, their leadership on doing module-to-module connectivity. That sounds to me like there's they've presumably thought to patent that, I would have thought, or technologies around it, and there must be equivalent things. And in some cases we perhaps know what some of them are, but in other cases it's a little bit more obscure what the patent portfolio of some of the players are.
The chip manufacturing capability as well.
We are certainly rooting for Rigetti and really for anyone in the ecosystem that is contributing to quantum computing and other technologies. Unfortunately, and this is confirmed, but not necessarily public, layoffs have hit the quantum universe as well. Unfortunately, one very large startup laying off about 20% of their staff, and mostly non-technical staff, sales, marketing, business development, and so forth. And one of the really largest startups out there laying off close to 15% of their staff. And we don't know if this is a precautious measure or a result of really miscalculating their run rate and burn rate, but certainly a sign of frostbite, if not more, hitting the quantum universe, even as we make our way into the spring.
I think these days, unless you have a revenue target that is substantially higher the previous year in terms of top line and bottom line, you're probably cutting. So I think this is in line with what we see in Silicon Valley like every other day.
Yeah, I just add, I mean, and speaking maybe to some of those individuals that are in those organizations or just exited from those organizations, they've not maybe been through this type of thing before. But to be honest, you know, as older folk have, I was involved in 2 very successful high growth businesses, but you know, we had waves of having to make very significant redundancies along the way. It is a part of the creative destructive process. And the other thing that sticks in the back of my mind, if you look back at that early history of Silicon Valley, some of the most influential startups ultimately came not from the original movers, but from people that had come off from original movers and ended up doing their own thing. So there could be, you know, there's a normal continuation for some of these businesses, but there's also going to be interesting new material to work with for new ideas and new organizations.
Yeah, this thing is, of course, very common. It's happened for decades in Silicon Valley. I think, though, the one thing that's maybe a little bit twist on it is that the employees who got laid off, you know, this might have been their first job. They may not have lived through some of these things like the 2008 recession or the 2001 recession. So for them, it's a new thing, and maybe it, you know, for people who are veterans, you know, they say, yeah, I've been through this before. So for those of you, it's your first time, don't worry, things will spring up again. And there probably will be a few new startups that come out of this, that people are laid off and they'll start up their own company. And that's the way tech is.
Indeed, and we are excited about many things in quantum computing and the other quantum technologies. Promised David to get back to some of them, actually, and I commend D-Wave for doing this. They held their Qubits conference just 5 blocks away from me in sunny South Beach, a very unique location, and it really was a fun, great event. And D-Wave has their message down. It's all about optimization. You put it into a QUBO, you make it as linear and as simple as possible, and you see results. They had a half dozen customers on stage using this in production, and it is still small, but successful. And I'm fairly friendly with the D-Wave team. Alan Baratz, the CEO, Murray Tom, the key architect. But even over drinks, they would not confess any secrets on their gate model, other than that they're very optimistic and excited about it. David, what did you learn about?
No, I learned because they were very kind in some conversations and pointed out some things that I was missing in one of my reports, and they were able to show me to the paper. Let me explain. So you know, when they first announced their gate model device, to be honest, in all honesty, I thought, great, I can see why they're doing it. It's a balanced story. It's going to play very well with the investment community. But hey, look, it's difficult. Get in the queue. There's lots of people doing this now. I didn't see why I could think they could play catch up on the gate model design. But what they're pointing out is that one of the key challenges for gate model superconducting circuit quantum computers is, how do you do your control logic? And you know, people worry about this because it's putting a heat burden in the dilution fridge that makes it difficult to scale up. And it is definitely one of the questions that certainly I'm always asking any superconducting circuit based architecture. What's your strategy for control logic, for keeping the fridge cold enough? And they point out that one of the technologies that gives you a unique way to tackle that is single flux quantum logic. And this is something that's been discussed around the community. CQC are notably developing that, because it's a technology they've also spun out and having a background in. But D-Web has pointed out, well, look, hey, that's what we've been doing. That's how we do our annealers. And so, and basically, single flux quantum, it's you're using Josephson junctions to do other types of circuit components rather than just qubits, where we normally know that. And the advantages are, well, it's actually very fast. It's actually very cryo friendly, and you probably still have noise issues to worry about if you literally try to put that control logic on the same plane as your qubits. But it's certainly a very strong story about the options you can choose to how you're going to do a more advanced style of control logic to help you scale up your qubits without spoiling your fridge. And yeah, so suddenly I was saying, yeah, I can understand how you're, that's a big step that helps you get a leg in the gate model game.
And I would also point out, again, something that's people miss, there's a lot of technology that D-Wave developed over the past 20 years with their quantum annealers that they will apply to their gate model machines. Things like silicon processing, wiring, integrating the control logic with the qubits, the mechanicals, how do you get the dilution refrigerators to work? So they have a lot of technology to bear, which will still be useful for their gate model machine.
But one question is that if optimization is the way to go, is that going to expand as the gate machine shows up? Or are we going to focus on optimization? Because it's not a bad market to focus on. There's a lot of really good apps there.
That question actually, Shahin, is answered in our quantum solver focus report that we just published. Thank you. According to D-Wave, they will focus on the optimization market with their annealer, but then we'll go into factorization and simulation with the gate model, and really bet on two horses in two different races at the same time. We'll see how that goes. They certainly also have a lot of expertise in working with customers. One comment that Murray made to me: yes, everybody now gives us credit, but we've been at it for 20 years, and don't forget that. David, we'll get back to you. Very dramatic sentence from you, and we'll have to explore that. Conventional quantum computing architectures are being disrupted.
Right.
You learned more this week about
it's for me it's a bit of a theme and just at the widest possible statement. I think there's a lot of people over the last couple of years now that have been introduced to quantum, and they've been introduced to quantum either maybe because they've been introduced to what we have to do about the migration to quantum safe cryptography and what the threat is, and they've been introduced by a relatively simplified model of what you have to do to build a quantum computer, or maybe they just are interested directly and they've got a story. Perhaps they've been educated by one particular player's program, and therefore there's a lot of assumptions built into that about, well, how do you go about building these things? And I'm just conscious that we're at a point. One of the things that's really exciting about the field at the moment is there's so many different strategies out there across the different startups. Almost none of these quantum computing startups, almost none of them are just me too, I'm trying to do exactly the same as him down the road. They all tend to have their own take on things. And there's one that I personally had not really realized the significance of one of the developments these guys have come out with, and it's parity QC and the LHZ architecture. And interestingly, we're talking about optimization and solvers and annealers a moment ago, and really that's where LHZ had originally come from. It was originally an architecture proposed to let you do a better, more coherent annealing style optimization problem. It was trying to do adiabatic optimizations, but the development is the guys at Parity QC have now established that you can do a universal gate model. They've worked out how you do a universal set of gates in their scheme. It's a slightly tweaked LHZ scheme. And the thing about it is it comes with some very interesting properties. And let me elaborate this, and it maybe gives you a sense of how it disrupts certain assumptions about what happens. So, for example, in their universal gate scheme, suddenly specifically controlled phase gates between any two qubits, they're easy to do between any two qubits, regardless of the connectivity, regardless of the physical connectivity. The logical qubits can be, the control phase gate can be implemented by simple rotations on individual qubits. Conversely, some of the other gates are more involved. Then to do certain types of single qubit rotations, you have to do a whole series of C0 gates. So there's an interesting difference in what it looks like as a set of quantum resources. It's going to be better for some things, and it gives you. It also, because what you're doing is effectively encoding the qubits into logical qubits in a particular way. It gives you certain inbuilt error correction properties. So you've got a robustness to bit flips, a bit like cat qubits in that regard. But you then need to pair it with the right physical technology. And it's going to give you an ability to do a certain scale of enhanced NISQ device. And it can be applied to a variety of different architectures. So that's one example. And cat qubits is another example. PsiQuantum's active volume architecture is another example. They're all things that are disrupting that easy introductory set of assumptions about how do you build a quantum computer.
So when I was reading this is after you pointed it out. So it came across to me as aligned with what we discussed in the last episode, that why don't I just go optimize the hardware to the specific application, and then I'm good to go, and I don't have to be so general purpose. But then this comes across as I have a general purpose way of optimizing it for your special purpose thing. Now, is that an architecture? Is that a methodology? Or is it all of the above? You're on mute.
It's very interesting. It's very interesting on a commercial term as well, because this Parity QC are doing, it's an interesting positioning, because they're unlike so many others, they're not building some hardware. They've very much styled themselves as the architecture company. And I think they've got some challenges maybe to communicate that to parts of the market that don't yet understand what really that means. But it does mean a very specific thing. It's right. This layer of how do you choreograph those physical resources to give you the logical capability that you need. Yeah. And to take your point, what they're saying is, no, we think we can capture more value by, again, patenting this particular style of approach, and then ultimately licensing it to multiple hardware players that are going to want to use this to build their own specific enhancedness device.
So this also goes a bit against the full stack momentum that we saw in much of 22, is like disaggregating supply chain once more. So it's interesting and was very, very interesting to see.
There's a lot of people out there doing some innovative things. I actually thought one of the more interesting things I saw this week was an award from DARPA for what they called underexplored technologies for quantum. And they gave the award to Microsoft, PsiQuantum, and Atom Computing. And I think what the message is, people would say today that the leaders are superconducting and ion trap technologies, but they want to maybe put some emphasis on some of these alternate technologies, because it is true. As I've seen, as I mentioned before, in the semiconductor industry, sometimes the technology that's most effective will change over time. In semiconductors, it went from germanium to silicon to integrated circuits to CMOS, that type of thing. And something very similar could happen in the quantum world too. So I guess DARPA recognizes that, and they've added some money into non-superconducting and ion trap technologies.
Yeah, I think it's very smart risk management on behalf of the government. Yeah.
So to wrap up, let's take stock of where we are, because even I'm a little lost here. Quantum winter, quantum summer. We have companies doing well. We seem to collectively become more and more optimistic about the hardware and the diversity of hardware approaches and the potential progress that they can bring as we move through 2023. At the same time, we have some very bad news out there. Some of it might be preemptive, which is smart and the right thing to do. But we clearly see the signs of struggle in the market. There was a very cute social media post, a bunny coming out of a hat, and that bunny was labeled as actually useful use cases. And in the corner of that same room was a little boy and a little girl, scared and crying. And the boy was labeled as quantum computers and the little girl as NISQ-era quantum computers. So where we at today? A good place, a bad place? And where will we be by the end of 2023?
I think it's important to differentiate between, if you like, the real underlying progress and how the perception of the mood music around quantum slightly developed. I personally, I'm very impressed by the basic underlying progress, both on hardware and on algorithms. Algorithms moved, what we know about quantum algorithms moved significantly forward in 2022, and I think it will continue to move significantly forward in 2023. What we know about fault tolerance, about quantum error correcting codes, moved very significantly forward over the last 18 months. And again, I think we'll move significantly further forward again in 2023. So this is great in terms of the health of the field overall. In terms of revenue opportunities in wider quantum, I think it's also very significant that the migration to quantum safe cryptography is underway. A lot of that effort will focus on post-maths based post-quantum cryptography, but there are important revenue opportunities for quantum vendors that are able to play with some of these supporting quantum-enabled tools for quantum safe cryptography. But the public mood, there was an excess of hype. There was an excess in the tech market in general. We've got to bear the hangover of that.
I would point out that there are some areas that may actually do well this year. That would possibly include quantum sensing, quantum components, and people doing post-quantum cryptography services. Those areas are doing well, and some companies, are taking the strategy to sort of broaden, participate in all those, including quantum computing, which from a revenue standpoint is good. It sort of balances out the revenue, and the only disadvantage of something like that is the resource requirements. You need more resources if you're going to get into all those areas. So, sometimes people argue that you're much better off focusing on one specific area, but each company has to make their own decision whether to focus, whether to broaden out. And I definitely have seen some companies take the decision to broaden out so they can get some more revenue in the near term.
So, André, thanks for making us do predictions after all. And it's not, too far into the year to do that. I think 2022, we averted a quantum winter. And I feel like we did it not by a big distance, because as David mentioned, I think, I personally was getting a little bit worried about the overhyping of it. I was catching up with Scott Aronson. I think 2023 to me is a year of building. It's a year of heads down work, fewer headlines, more time in the engine room, more time on substance. And I think that's really healthy. And I'm hoping that that's how it pans out. And I think you need periods like this to really build the foundation and the bench strength and the supply chain. A lot of the stuff that's underneath the iceberg that needs to happen, so that when it does come back in a real way, it's got the backing to do a good job. But we need quantum advantage before this thing is going to fly, and we don't have that yet.
There's probably one other silver lining in the cloud, which is I don't hear people talking and complaining so much about the fact that they can't find engineers. I think the workforce issue is a lot less than it was now than it was a year ago.
Yeah. I want to add another thing, and that's mainly because I do track the HPC supercomputing market, and I consider that community to now become a lot more comfortable and conversant, and quantum computing is very much on the agenda in a consistent way. That was not the case a couple of years ago. I've talked about the University of Jülich in Germany, who I consider to be one of the main pillars of expertise there. They have their own 5,000 qubit D-Wave. They just announced the protein folding application that looked pretty cool, very simple model, but still pretty interesting. They've done other things along those lines. There were a couple of applications that they talked about. Argonne National Labs, the DOE labs in general, Brookhaven National Labs, we mentioned it last time, with their quantum communication and quantum sensing. and even some of the upstream materials creation that they do. I think all of that is also bodes well for quantum computing, because these HPC guys have the application, they have the technical depth, they've got the funding, and they like to go make this happen. And I believe that we might just see quantum advantage there first.
Humans overestimate the short term and underestimate the long term. We will not be at 125 billion, whatever way you slice and dice it, by 2030, maybe 10 billion. The hardware will be able to deliver that type of value. Will our use cases, algorithms, and solutions be able to deliver on it? Remains to be seen. This concludes Season 2, Episode 4 of the Quantum Analyst Roundtable. Round and round we go, and we're extremely grateful for that. It is difficult times out there in the quantum universe for many, and our thoughts and love goes out to those, especially the Pleximo team that is going through very dark times right now. Reach out to them if you haven't.